Ever wondered how your phone's AI knows to suggest the perfect song for your mood? Or how a search engine connects Einstein to relativity without you spelling it out? It all starts with a knowledge graph, a structured web of facts, entities, and relationships. But here's the catch: these graphs are incomplete. Think of them as a puzzle with missing pieces. That's where knowledge graph completion, KGC, steps in. Its goal is to infer those missing links. Traditional KGC methods. They're like trying to solve a puzzle by randomly shuffling pieces. They propagate messages between nodes like Paris or France, but often get overwhelmed by noise, irrelevant connections that distort the picture. It's like trying to hear a conversation in a crowded cafe. Important details get lost in the static. But what if we could teach AI to focus on the right clues? Enter Semantic-Aware Relational Message Passing, SARMP, a breakthrough approach that rethinks how AI navigates these graphs. Let's dive into how it works. First, imagine your AI is a detective exploring a knowledge graph. Instead of blindly following every connection, it evaluates the semantics of each link. For example, when trying to link Albert Einstein to physics, it asks, is this relationship meaningful? This is achieved by mapping entities and relations into a shared embedding space, a mathematical representation where similar concepts cluster together, like a semantic map. Next, SARMP uses top K selection to filter out noise. Instead of processing every possible connection, it prioritizes the most relevant ones. Think of it as narrowing the search to the top 5 clues that matter. This reduces computational overhead while sharpening the model's focus. Then comes the core innovation: multi-head attention. Picture this as a team of specialized experts. Each head analyzes different aspects of the data. Some focus on direct links, others on indirect patterns. By aggregating these perspectives, the model builds a more nuanced understanding of relationships. For instance, if Alice is Bob's sister and Bob is Charlie's brother, SARMP's attention mechanisms can infer Alice is Charlie's sister by recognizing transitive patterns. Why does this matter? Traditional methods struggle with such indirect reasoning. They treat relationships as static, missing the dynamic interplay of context. SARMP, however, captures these subtleties by combining semantic awareness with attention-based reasoning. In real-world tests, this approach improved prediction accuracy by up to 2.6% on benchmark datasets, like giving AI a sharper lens to spot hidden connections. So the next time your smart speaker answers a question, remember, behind the scenes, algorithms like SARMP are working tirelessly to fill in the blanks. They're not just memorizing facts, they're learning to reason, infer, and connect the dots in ways that feel almost human. Thanks for watching. If you want to explore how these techniques power everything from recommendation systems to scientific discovery, hit subscribe. Stay curious, and we'll tackle the next big idea in AI together.